we'll get started. Before we do, is there any questions? Let me front run any questions about the assignment. I changed it slightly so if you already started it, it doesn't affect you at all. There was some confusion about which version of Ghostery. Ghostery has become more commercial, and so now they have like paid things and they have bundles and a bunch of stuff. So it's just the free basic. They call it an ad blocker. For me, it's more about like tracing cookies and seeing where they're coming from. But that doesn't really sell, I guess. So now they focus on ad blocker as like the description of it. But anyways, it does a lot more than just block ads. It's not like ad block where it just blocks ads and that's all it does. It's doing some cookie stuff, and it should show you some information about cookies. So the best way to install is actually just, if you go to Chrome, for example, go to the Chrome store for extensions and install it directly from the store instead of through their website, because their website's kind of confusing. And you should be able to do it for free, and you should not have to sign up, put in a username, password in order to get it. But anyways, and if you want to criticize the website for letting you find it, go ahead. Because I was kind of freaked out that you might have to pay for Ghostery, I looked for a free option that would be similar. And so EFF, which is a famous like sort of advocacy group in the US for internet laws and things like that, they have a similar tool called Privacy Badger. And so I thought, if you want to analyze that instead, go ahead. I don't know much about it. I think it's a little simpler. So if you want like a positive usability study, you might opt for that one. If you want more of a negative one, because things are complicated and you probably would have a lot more to say with Ghostery. That's my kind of feeling about it. But anyways, you're free to choose between them. If there's some other privacy tracker that you know about that you really want to do a usability study that's not these two, that's probably fine. Just shoot me an email with the name of it and I'll check it out. But yeah. Okay, other questions about the assignment, about last lecture, anything? All right. Okay, so in the last lecture, we were talking about cookies and the policy, basically the cookie policy. Which is implemented by the browser. Okay, so let me just to sort of remind ourselves, I'll show you how cookies work, and we'll think about the scenario more from a tracking standpoint or a privacy standpoint. So how is it that, you're looking at Boots on like thebay.com, and then you go over to Reddit and you see the exact same pair of boots that are like in an ad on Reddit or something like that. So what will happen is, let's say we have a user. They have a brand new laptop, so no cookies. They go to some store, call it an e-store. That might actually be a real URL, and I'm not responsible for anything that's on that website. And so what they'll do is they'll send a request, like give me the information, and they'll get back a response, which is the website itself. And inside the website, it will have a set cookie command. And so there's a bunch of parameters, and I'll show you what a cookie looks like and what the parameters look like and things like that. But the main thing is that this cookie will be for eStore. .ca. Okay, so what Alice's browser does is it creates a cookie jar, and it says, okay, I just got this cookie for eStore, and it has some value. We won't care about the value itself. Okay. Now, eStore itself might have say a relationship with Google. So maybe they embed Google Analytics on their website so that they can understand who their users are. If they come from Google search engine, what were the search terms that they used and things like that. Okay, so what that looks like is when you're done requesting the first website, remember when the website comes out, it's an HTML file, but it's going to point to a bunch of other resources. So say, go grab this image from here, go grab this JavaScript, or whatever the case may be, okay? So then your browser will go, and it might request some script from analytics. I don't know if this is the real URL, but anyways. Okay, and so what that would look like is, it's because in the website that you got here, in the response, there would be like some HTML that says something like script source equals, you know, whatever, analytics.google.com. Okay. So this would be in the actual URL, or sorry, in the actual HTML of it. So that's why you're going and grabbing the script in the first place. Okay, then when the response comes back, Google does the same thing. It says, I want to set a cookie. And you will add it to your store. Okay. Now, because you're on the website estore.ca, so when you're looking at your browser window, that's the site that you're on. That's if you look in the URL bar, it's on the store.com, okay, or estore.ca. So that's the website you're actually on. Yet you're going and you're fetching something from Google, and Google's saying, I want to set a cookie, but you're not actually on Google's website, okay? So in this case, we call Google a third party. So this is called a third party cookie. And you may have your browser configured that it won't accept it. So you could configure your browser to say, hey, I don't want any third-party cookies. Just give me first-party cookies. And then that's fine. So it will let you set this cookie. So this one would be fine. But then it would not allow you to set the second cookie. Okay. I'll show you that setting later. But anyways, for now, we'll just assume that third-party cookies are set. Okay. So Google has now set a cookie. All right. Now, let's say that you go over to some other website, like a web form. And so you go here. So this is like some completely new site. Has nothing to do with this. You're done looking at the store. So you go over to the web form. It also may set a cookie. Okay, so now you have another cookie. And let's say that this web form uses ads, and Google provides the ads. Okay. So what will happen is when you get your response here, once again, you'll have a website. And sorry, this is getting a little messy. But in that website, in the HTML, it will also have, you know, some embedded, you know, script. ads.google.com or whatever. Okay, so the user wants to load that. So now what the user will do is they'll go over to ads.google.com. They're making a request for the script, the ad. Like, so this is just some script that would fill in an advertisement, okay? All right, so let's pause here. So Google sees that this request comes in. Now remember, on every outgoing request, your browser is going to decide whether it wants to put a cookie inside that request, okay? So your browser is, first you went to eStore.ca, you stored a cookie. Every time you go back to eStore.ca, that cookie will get sent, okay? Then your browser goes over to analytics.google.com. Never been there before, don't have a cookie. So it sets a cookie for the first time. In this case, I'm glossing over this detail, but imagine that it's not going to set it for analytics.google.com. It's going to set it for any google.com domain. So this is possible, and I'll talk about that later, okay? So you set the cookie, so then that's fine. Now, every time you go back to any google.com, mail.google.com, search.google.com, whatever, then that cookie is going to get sent, okay? Then you go over to the web form, never been there before, first time, so you set a new cookie, and every time I go back to that web form, I'm going to send this cookie, okay? Now, finally, I go to ads.google.com, okay? So this is the first time I'm visiting the same site twice, okay? So I visited google.com before when I visited analytics.google.com. Now I'm visiting's the wrong word. My browser's downloading a script from it behind the scenes. Like I don't even know that it's happening, okay? But I'm going to ads.com. So when I send this request, what my browser does is it goes through my cookie jar and says, should I send the cookie that belongs to eStore.com? No, because it's going to analytics.google.com. Should I send the cookie that goes to google.com? Right? And then it will decide. And so let's assume that the cookie is set so that it will go to any google.com resource, okay? So in that case, it will say, yes, I'm going to put that cookie in, okay? So when this request comes, it has the cookie for google.com. Okay, now what Google will do is when they set this cookie, they're going to say, hey, there's this user. I don't know who they are because it's a new computer. I've never seen them before. But this is the value that I set for them. Okay, so here's my cookie. And here's the value that I set. Okay, so then when you go back to ads.google.com, they'll go to their little table and they'll say, have I ever seen this cookie value before? So they'll go through their table and they'll say, oh yeah, I've seen it. So it was this user. I don't know who they were, but last time they came to me, they were browsing on eStore.ca, okay? And when they sent the request to get this file, there's different ways I could do it. Like, how do I know that this request was a sub request of them downloading eStore.ca? It might be that when I gave this script to eStore.ca, I made it unique. So it has a unique, it's not just script.js, it's like some random number or something like that. Then I know it's always coming from there. There's also things called refers, and so you can see what website referred you. So there's different ways of doing it. But Google.com would say, okay, I set this cookie, and this person was browsing eStore at that particular time that I set it. So they were on eStore. So we'll call this the refer. Okay, so now we see that, hey, this person came back. They were just on eStore. That was the most recent website where I saw them. Now I have to decide what ad to show them. And eStore is one of the companies that advertises with me. I can show them an ad for whatever, Lululemon, The Bay, whatever you want. But they were just on eStore. There's a good chance that they might click on that, right? Because I know that they're at least interested in that website. So what ad are they going to choose? They're going to choose the eStore one. Okay, so then they'll send back a response. Which goes all the way up here. And it might be an ad for eStore. Okay, so that's how essentially, that's why you can be on one website, you're looking at something, then you go to a completely unrelated website and you start seeing ads that pertain to what you've searched for in the past, okay? So the way it works is both eStore.ca and Webform, they have to have a common third party involved, okay? So in this case, it's Google. Now, if you run the numbers, Google is on like 80% of sites or something like that, and Facebook's on like 50%. I forget what the exact numbers are, but it's more likely that someone like Google or Facebook is on a website than not on that website. Okay, and so they can trace you as you go. Now, if you go to another website, a third website that doesn't use Google, right, then obviously they can't trace you. And if you go back to Google, they don't know that you went to that website. Okay, so they're only tracing you around websites that Google has control of, or they have some embedded content on. Okay, questions about this? All right. So let's do the same thing, but like look at a browser while doing it. So I'm going to fire up a private browser window. So that means that my cookies are now reset. So if you ever want like a fresh browser with no past cookies, that's how you do it. Okay. So I don't have any cookies. My cookie jar is empty, at least in this instance. There are different controls, so every browser is going to look different. Apple kind of cleaned up their controls a bit, so now they just have one generic thing that says prevent cross-site tracking. So that disables third-party cookies, and I believe, if I'm not mistaken, there's also this like do not track header that it turns on. You don't have to worry about what any of that means, but just for your interest, if you know that stuff. Okay. You can also see you could block all cookies, for example, or things like that. Okay. So let's start with it with just prevent cross-site tracking. So I tried to find a real garbage website. I was looking at BitTorrent sites, but I couldn't find one fast enough. I found a download page for a BitTorrent client. And I used to do dictionary.com because it used to have so much like tracking, but it doesn't anymore. So whatever, this is just an example website. Okay, so if I go into the tools, I can see, first off, this is something we've seen before. These are all the files that came down when I asked for this website. So I got the basic HTML file, the root site, and then it said, okay, go grab some stuff from the same domain. Go grab this SVG file from Outbrain.com. Outbrain.com is an ad agency. Yeah, anyway, so you can go through, you can see Trackonomics. That sounds probably like a tracker. And so there's all these like weird kind of scripts. Then I can go and look at the actual cookies themselves. So these websites were third parties that I visited, but because I have prevent cross-site tracking turned on, they were not able to set cookies. So these are third-party websites. So this one wanted to set a cookie, but my browser said nope. This one wanted to set a cookie, my browser said no. This is the first party. So I'm on this website. So this website was allowed to set cookies, and then these ones, same thing. Okay. Now I can reload it with this turned off. And now you can see that some of these third parties were able to set cookies. So some of them didn't for whatever reason, but anyway, some of them did. Okay. All right. So what is a cookie? What does it look like? Let me. I'll put this into the notes, and then we can draw over top of it. So we're looking here at the first party cookies. These and the ones above it are third-party cookies. So cookie is really simple. All it is you get to name it whatever you want, and you get to store a value. Okay, so when this website sets a cookie, they decide, okay, I'm going to set a cookie called JID underscore. So that's the name of the cookie, or the ID for the cookie. Then they can put whatever value they want. So the idea is that they would have a database in the back end for like a JID database or whatever that is. And then they would have all of these values, okay, that they've assigned. And then they would have whatever other information they wanted to store about the person that was browsing. So GA1.2, blah, 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 blah. Okay, and then they would have some information, all right? And so why do they have a whole bunch of different cookies? Well, they're probably used for different things. So that just goes to the internals of the website. I don't know how the website works. I don't know how they set it up. A lot of times they're using software. They're just using modules and turning it on. That module sets a cookie. Could you get away with just one cookie for the whole website? Probably. Sometimes, the cookies will behave slightly different. So you can see a few things over here that start to look a little bit different between them. But anyways, okay. The next thing that's set is the domain for which you'll reply. So does this cookie, when should this cookie get sent back? So I'm at filehippo.com. I'm storing it. And I want to see that every time you go back to filehippo.com. Okay? But do I still want to see that cookie if you go to images.filehippo.com? Right? And so this is where the policy comes into place. Okay, so the browser has to decide, are they sending that cookie every single time you go to any, for example, subdomain of that website? Or is it just when you go to that exact website? And so instead of the browser deciding, what the browser decided was, we're going to let the websites decide. Okay, so the websites are going to tell us what they want, and then we'll honor it. But we have some rules, so there's a few things that you can and cannot do. Okay, so this is called the domain. Sometimes it's also called the scope. And you'll notice, for example, it's very small, so maybe you can't see it that well. But they almost all look the same, but there is a slight difference. So some of them have a dot before them, and some of them don't. Okay, and so the dot actually means any subdomain, and no dot means that exact domain only. So let me, I'll just write a few notes about that, and then we'll keep looking at the cookie. Okay, so when a website sets a cookie, first off, the browser has to understand what site is it that's setting the cookie. Okay, so let's take an example like encs.concordia.ca. Okay, so this is the website that's setting the cookie. Okay, now the website will say, I want to see that cookie every time the user goes to another website itself. Okay, so here are your sort of options. You can specify encs.concordia.ca, and then it will only go to that exact domain. Okay, so for example, let's say you go to, I don't know, images.concordia.ca, then that cookie will not get sent. Okay, if I go to a subdomain, users.encs.concordia.ca, .ca, that won't get sent because it's not the exact same domain. Okay. Now, where we're going with all of this is we're going to something called the same origin policy. Okay. This is actually means exactly the same origin. Okay. It will be a little more complicated, but the first thing about whether something's the same origin or not is that the domain name is exactly the same. Not a super domain, not a subdomain. It's the exact same domain. Okay. Now, let's say I want it so that if someone goes to users.concordia.ca, then that cookie gets sent. Okay, so I want all subdomains. So that's where I would add a dot. And just to make it clear, I'm going to add an asterisk, even though that's not the notation. But to me, like an asterisk means wildcard. So logically, that's more clear. So here, if you go to users.encs.concordia.ca, then it would get sent. If you go to images, it's still not going to get sent. Because it doesn't match this string, because it's this is like star, so anything.encs. If you go to the exact same domain, it also matches. So it's not that it has to be a subdomain. It's either a subdomain or it's the exact same domain. Okay. Now, what if I want to go up a domain? So I'm on encs.concordia.ca, and I want it so that any concordia.ca, anything that goes to concordia.ca, this cookie is going along for the ride. Okay. Yeah, so I can do that. So that's valid. So I can do star.concordia.ca. And this time it's going to all of these subdomains. Okay, can I keep going? Could I do star.ca? So like maybe I want my cookie to be sent to Facebook. That's not .ca, but I want it to be sent to google.ca. So I'm Concordia, and every time someone goes to google.ca, I want my cookie to be sent to. So can I do that or not? No. Okay, so syntactically I can. Like I can specify, there's no syntactic rule, but it's just an accepted policy of browsers that you shouldn't be able to do this, okay? If people did it, it's probably because the developer doesn't realize what they're doing, right? So sometimes, like for example, let's say you're facebook.com and you want your cookie to go to instagram.com. You own both of those domains, right? You can't list out a bunch of domains. So your choices are, you can do star.facebook.com, but then it's not going to get sent to instagram.com. Or you could try and do star.com. Then it would get sent to instagram.com, but it also gets sent to google.com and every other website, okay? And so it's too stupid. So this is disallowed by policy. So just the browsers decided that they're not going to do this. Okay, let's say that I set it for, well, let's just go back to this example. Would this get sent to www.encs.concordia.ca? So if I set my cookie to be, I'm just going to sort of try and denote where. So this is what I set as the domain. Each of these lines. So if I set my cookie, I'm encs.concordia.ca, you come and visit to me, I set my cookie to encs.concordia.ca, that's fine. User goes away. Tomorrow they come back, but they go to www.encs.concordia.ca. Okay, why? Okay, so So, okay, one answer could be yes. So they are basically the same domain. Okay. Now, if you've ever configured a web server, could you have www go to a different IP address than just concordia.ca? Okay, so a lot of people get into trouble, or they'll set up their website and it will work when you go to concordia.ca, but then you type in www.concordia.ca and it's like down. The website's down. So at the internet level, www isn't actually special. There's nothing special about it. It's just a subdomain that's often used. It's a common domain. So the thinking goes back to, this late 1900s. And the idea would be like an email address might be at concordia.ca, but if you wanted like the website for it, you would put it at www.concordia.ca. And then if you had an FTP server, it'd be at ftp.concordia.ca or something like that. So the idea was that you would give the website its own domain. But now like the website is kind of the most important thing attached to a domain. And so most people just put it at the root domain. As opposed to like putting it in a folder. But anyways, www is a subdomain. Just like images, just like ads, it's no different. So the answer to this question is no. So if you set a cookie for encs.ca, it would not get sent to www.encs.ca. If you want it to get sent, you'd have to put an asterisk in front. Yeah.
We can use dot between domains?
Sorry. Can you use dot between domains?
Yes, for example, I want to add a domain, register a domain.
Yeah.
Can we use dot between them? For example, yahoo.www.yahoo.
Yeah, okay, I understand your question. So when you register a domain, you register the actual, like the root domain. I don't know what the proper term is. So .com is called a top level domain.
Yes.
And then concordia.com is something, we'll just call it a domain. So you don't register images.google.com and then someone else can come along and register ads.google.com. You register google.com and then in your DNS record, you say, oh, by the way, if anyone's trying to get to ads.google.com, send them to this server. And if they're coming to just concordia.ca, then send them to this server. Or you can have it so like if they come to any subdomain, just send them to the same place.
But I don't understand. Is .com like concordia.ca?
No, .com is like .ca.
What about the between .w? You have one dot after www and one of them is after encs.
Yeah, that's right. Yeah, so.
But in real, we can use maybe I don't understand, but we can use the dash. But I have never seen dot between them.
Okay, so your concern first. So you're like, I've seen www.concordia.ca. I've just never seen www.something-else.concordia.ca. Yeah. So it's true. So normally you would append or prepend www to the top, like to the main domain name itself. Yeah. So this was just for the purposes of an example. You could do that. There's nothing illegal about it. But yeah, you're right. It's sort of unconventional. Yeah, you're welcome.
What if I have a CNAME record in the DNS server? ENCS and www.encs point to the same server.
Yeah.
So what's wrong with that? And if I set the cookie to ENCS and I go to the www.encs.
Yeah. Yeah, so the only thing is that the browser doesn't want to check that. So that would require the browser to go and then check your DNS policy. And then your DNS might change. So next time you want to send the cookie, it has to go and check it and make sure. So that it's just too complicated for the browser. Yeah.
So the browser only checks the domain. It doesn't care about the IP.
Exactly. It says it checks. So when it's setting it, it's going to check the domain. And when you're going back to a website, you're sending a request, then it's going to check where are you going, and then what's in my cookie jar. Okay, yeah. So what it will do is it will basically scan through, not just the cookies here, it'll scan through every cookie, but it will basically be like, oh, I want to go to ads.filehippo.com. So I'm not going to send this cookie because it doesn't have the dot. This one has a dot, so I'll send it. This one, yeah, it just goes through. Okay, you can also specify a path. So if you want to go to, if you only want the cookie to be sent, for example, actually, let me just say one more thing. Remember that the setting site here is encs.concordia.ca. Could encs.concordia.ca set a cookie for facebook.com? So could it be a completely unrelated domain? So we know it can't send it to star.ca or star.com. But so for example, if it was instagram.com, could they set a cookie and say every time the user goes to facebook.com, like maybe they set the same cookie value. So they're like, all right, I'm facebook.com, so I'm going to set a cookie with the one value for facebook.com. I also own Instagram, so I'm going to set the cookie with the exact same value for instagram.com. So are you allowed to set a cookie for another site, for a third-party site? And so once again, this is a policy decision, right? So there's no right answer or wrong answer. It's just what did browsers choose to do? And so in this case, they said, no, we're not going to allow you to do that. So this is disallowed. Yeah.
Is policy for the web browser or for website?
It's for the web browser itself. So if you didn't like this rule, you could design your own. You could download the open source of Chromium, go into their cookie policy and just change that. And then if websites started sending these kinds of cookies, your browser would accept them and it would send them back to requests. And all the other browsers, it wouldn't break or anything. It would ignore the cookie. It would say, you're not allowed to do it. It would drop it.
Thank you.
Yeah. Okay, so then you have path. So for example, my website is users.encs.concordia.ca/tilde-clark. So if I wanted it so that I want to set cookies, but every time someone goes to, like, say, Manon's website or something like that, then I don't want that cookie sent. Okay, then I could use this path constraint. So if I want this, if this is the setting site, and I don't want this cookie sent, then what I would do is I would use the path. I won't go into details of it because almost no one sets paths. As you can see, like, it's very uncommon. You have to have, like, some really specific reasons, but usually it's always. So backslash, just a simple slash like that means any path. So when path equals slash, that means any path. Okay, the next thing is an expiry. So how long does a cookie last? And you can either set an explicit date or you can say when the browser closes. Okay, so session in this case means when the browser closes. Now, because I'm in private browser mode, it's going to actually delete. So let me explain this different. This is what will happen automatically. So your browser will do this automatically, but this is the website. So the website's saying, hey, I want this cookie to kick around till 2023. Okay? That doesn't stop you from removing it. If you want to remove it, you can. Okay? So you can always go in and clear your cookies yourself. Okay? But if you don't do anything, if you're just passive, then the website will want this cookie to stay. And then once you go past that expiry date, then the browser will stop sending the cookie on your behalf. Okay, but this is decided by the website. All this information, it's not me that's deciding, it's the website that's deciding it. So this is when browser closes. And then this would be some date. Chosen by website. However, the user can always delete. So now Safari and other browsers have better control where you can, like, it will show you all the sites that have ever set a cookie, and then you can just be like, I want all cookies for filehippo.com gone or whatever, and you can just do it in one click. So it's, and then you can get extensions and things like that to like manage your cookies and things like that. Okay. So user can always delete, and then private browsing mode. As soon as I close the browser, it clears all the cookies. Okay, all the cookies that were set during that session. So that's the other thing that it does. Okay, the next thing is the size. So the size is really just a function of this. So you can see, for example, this is really small, has a small ID and a small value, so it's only 11 bytes. This one, you can't see the whole thing, but you see ... So it's a big value that's being stored there, and so that's why it's 196 bytes. I don't know what the maximum is on value. I assume that there is some maximum, but I'm not sure what that is. Okay, then we have 3 flags. Same site is kind of new. I don't know the full details of it, so I'm just going to skip. I'll skip explaining it. I should have read about it before, but I'll tell you about secure and HTTP only. So they actually sound maybe slightly different than what they do. Okay, so secure means, anyone want to guess what either of these two mean? HTTPS or HTTP. Okay. So one of them is going to be about whether you would send this cookie if you're sending it over a non-HTTPS connection. Okay. Why is that important? Why would you care? Okay. So lots of stuff are in your cookies. So as a user, you might care yourself. But the most common use, or one of the 3 most common uses of cookies, is to keep you logged in to a website. Okay, so that cookie value becomes your login credential. If I can steal your cookie value, then I can log in as you. Okay, and if it's not sent over HTTPS, then it's in clear text. So anybody that's between you and the website, your computer, your Wi-Fi router, whatever, your ISP, they can pull those cookie values out. Okay, and they can log in for you. So generally, if it's like, let's say I go to a website, I change the font on the website, I want that to stick. So next time I go back to the website, it will show it to me in the same font. Who cares if that cookie goes over the wire or not, like in plain text, right? But if it's a session ID, then you would want to protect it, okay? All right, so the secure flag, that's exactly what it does. So what this says when it's checked is it says only over HTTPS. Okay, so if we go back to the actual website here, so we can see that this cookie was going to filehippo.com. If we go back to like what was actually being sent back and forth, you can see the lock here. You can see that this entire website, everything's served over HTTPS. So that cookie is getting sent regardless. Yeah, so sometimes there's websites where, and you'll notice also the website itself is over HTTPS. So the root pages and then all the resources it loads are also over HTTPS. 5 years ago, 10 years ago, you might be on an HTTPS website, but the images and stuff like that would be coming down over just HTTP. So it would be weaving together mixed content. But yeah, nowadays there's been a big push to just, and SSL is so efficient now that it makes sense to just turn it on everywhere all the time. So anyway, so that's what the secure flag does. Now, if the secure flag does this, then what's HTTP only? Because that sounds almost like the opposite. Like you don't want it sent over encryption.
Only HTTP protocol.
Not JavaScript.
Not JavaScript.
Okay. So this is HTTP not as opposed to HTTPS, but HTTP as opposed to a JavaScript request. So when you load content into a website, it could be because you downloaded the HTML file, and so your browser's like, oh, I have to go get this image. Okay, it's going to use HTTP to go grab that image. It could also be that you loaded a script. Now, the script itself you load over HTTP. So the script comes down over HTTP. But inside the script, when you start running it, it's being run on your browser. So scripts are client side, right? So it's running in your browser. Now it can go and say, give me a picture from here and give me this and give me that, okay? And those aren't going over an HTTP request. It's not your browser deciding to go fetch that image. It's the script itself, okay? And so what you can do is you can say, if the script starts opening up connections to facebook.com, Facebook can say, I don't want my cookies to go along for the ride. Okay, I just want it when it's going over HTTP. Now there's other things too. JavaScript's not the only thing that can load resources. There's like ActiveX, and there's a bunch of weird other technologies, but usually aren't used. Okay, so this is all a cookie is. So it's just, yeah, it's a value, a tag, a value, some scope about when it should be sent back, some expiration date, and then some flags that will make it sent in less circumstances, essentially. And remember that all of this is set by the website. So the website is the one that's setting all these parameters. They're choosing them. It's not your browser, it's the website. But your browser's storing it, okay? So this is what's stored in my browser, but all those values were set by the website, okay? Because it's in my browser, I control it. I can delete them. If I wanted, I could go in and change stuff, right? Like I could add HTTP only flags to all my cookies or something like that. Like it's my browser, it's my cookie jar, my data. I can do whatever I want. The website might not work because they're expecting cookies in cases where now they're not being sent, but it's under my control. Okay, so I can delete them at any time. I can use private browsing mode. I could, in theory, edit them. I can say use third-party cookies, don't use third-party cookies, so I have a lot of control over stuff. Okay, questions about this? Okay. All right. Last year we had a break in the lecture at this point, and so I started the next lecture with like a recap, but it's kind of redundant because it's everything that we saw. But let me just paste it in because it's at least a less sloppy. It's a less sloppy diagram, and then we can just we can talk through it just to make sure everyone's on the same page with this stuff. Sorry, that didn't work for some reason. There we go. Okay, so same idea, but maybe it's a little bit clearer. So when I go to a server for the very first time, I get my response back from the server, and it says set a cookie. Okay. So in my browser, this whole thing is my browser. I have a cookie jar. So what I'm going to do is I'm going to look at the cookie, and I'm going to set it, and I'm going to record all that information. So like what the scope is, where it came from, is it HTTP only or whatever the case may be. Okay. Then what will happen is I'm going to parse the request. So the request is, say, an HTML file. And so it will say, oh, okay, great, you got the root page, but there's a bunch of images missing. Okay, so then my browser is going to go and it's going to create new requests to get all the resources. Okay, so let's say it creates 4 requests. Every single request is going to take a look at my cookie jar. Okay, so I have some browser policy that's going to say which cookie should I include and which cookie shouldn't I include. Okay, so let's say that, for example, this first request is going to ultimately go back to the same server that set the cookie. Then I'm going to include this cookie that it just set in my request. Okay, and maybe I have another cookie that was already set for this server, so my browser is going to throw that one in. Okay, this is a totally different server, so maybe I don't have any cookie in my cookie jar that matches it, so I don't send any cookies. That's fine. This request is also going to a completely new server, but if I have a cookie for this server, okay, so this server is not the same as this server. Let me do this so it's a little clearer. So server 3 is not server 1, so I would have to have a cookie for server 3 because I visited server 3 in the past, or one of its subdomains or something like that. And then same with server 4. Okay, and so what my browser is doing, what the policy is doing, is it goes through every cookie and it basically says, does the domain name match what's being requested? So the request is going to server 1. So when I go through my cookie jar, I'm looking for a domain match. And remember that they might set wildcards and things like that. So I'll take that into consideration. Okay, so I just slide through my cookie jar. I look at every domain and I'm like, does it match? And if it looks close, then I check the wildcards and make sure that it really matches. And then assuming it does match, I don't necessarily send it right away. Then I have to ask myself, is the conditions of the flag is suitable? So let's assume that the answer to this question is yes. Then I go to the next thing, and then I ask, are the flags going to stop me from sending it? So either there's an HTTP only flag set, and I'm trying to do this over JavaScript, which it doesn't match this diagram because all of these requests are coming from HTML, or I'm going and it's not over an HTTPS connection, and the secure flag is set on the cookie. Okay, so that's what would prevent me. So let's assume the answer to that is no, the flags aren't preventing me from sending. Then I ask myself, okay, I haven't looked at my cookie jar in a while. I know that these things have expiration dates, and so I better check and make sure that it's before the expiration date. So if the answer to this is yes, then I send the cookie. If the answer is no, I actually delete it. So not only do I not send it, I delete it. And in any of these other cases, like say the answer here is no, then I just don't do anything. I don't delete it or anything. It's a cookie, it doesn't match, so I just ignore it. And same thing with the flags. If the flags don't match the condition, I don't send it, but I don't do anything else. I just ignore it. Okay. But if it is after the expiration date, then I'll delete it. Okay. So cookies are used. They have like 3 good uses and a couple bad uses. So the main use for them is they keep you logged in to a website. The second thing they can do is they can allow you to configure a site. So you can personalize and have it stick. So usually you think of this as first you log in and then you say, I want it to look red instead of blue or whatever. And then if I go back and I'm not logged in, then it goes, I have to log in to get the customization that I want. That's just a selling feature of the website. So they're trying to get you to create an account because they want your email address and blah, 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 blah. There's no reason why they couldn't do it without you logging in. Okay, they know who you are. They're tracking you through a cookie. And so they could remember that information if they wanted. Okay, the third thing that we haven't talked about, but we're going there, is sometimes you want to embed content from another website in your website. And what you would like it to do is you want it to look like what it would if the user was on that website. So that sounds very vague. Let me just give you an example. So let's say I'm a blog and I have a news article. I might embed Facebook. Okay, now I could embed a like button. And the idea would be if you click that like button, it will actually like it on Facebook. Okay, but how does that work, right? Like if you click the like button, like this is my blog. I don't know who you are. I don't know who you are on Facebook. And so what I want to do is I want to embed it, and I want to have it so that when you click the button, if you're already logged into Facebook, it will just automatically like make you like it on Facebook. Okay, I can't get that to happen myself. If I could get that to happen myself, then every visitor that comes to my website, I could force them to like my article, right? So the user has to click on it in order to have that action take place. So how does that work? Like if the website doesn't control what I send to Facebook, right? Then it seems like I can't be logged into Facebook, okay? But if it can control it, then it could just make me like without my permission. And so that would be bad as well. So what ends up happening is there's a sort of middle road where you can embed something from another website. You are logged into that website, okay? But I can't, if I'm the person that's embedding that content, I can't reach into that embedded content and start messing around with it. In fact, I don't even see it. I just say, here's a black box. Facebook is going to put information into that black box, okay? I don't control it. I don't see it. Whatever you do in that box, I have no idea what you do. That's between you and Facebook. I'll never know, okay? But because it's between you and Facebook, your cookies will get sent. So Facebook will be like, I know who this person is, okay? So like, for example, it might be like you read the article and then at the bottom it says, 3 of your friends like this article, and it has their names, okay? Do I know who your 3 friends are that like the article? Because it's on my website, it's my blog, right? I gave you that website content, right? And so the answer is no. Like, I don't know who the 3 friends are, right? That was something that Facebook told you that I had no say in, other than giving Facebook a box to put that information, okay? So anyways, this is sort of confusing maybe now, but we'll spend a lot of time on it. So hopefully it'll be clear by the end of this lecture or next lecture. But it lets you embed from another site.
So examples that you were talking about, it's Iframe, where when you have an Iframe, it communicates with the other website.
Yeah, exactly, yeah. So this is called, so when I go and I ask for it from Facebook, it's a request, right? It's the same as going and asking them for an image or whatever. They're all requests. And because I'm not asking for information from the site I'm on, I'm asking it from a third party. So it's kind of like a third party request, or the term that you might have heard is cross-site request. And if you've heard this term, you actually probably haven't heard this exact term. You probably heard cross-site request forgery, which is an attack that on cross-site requests. But for now, this is cross-site requests, and later we'll talk about forging cross-site requests. Okay, so these are the main three features. Keeps you logged in. You can personalize a website, have it stick, and you can embed content from other websites, stay logged in on the other content, and things like that. The other ways that are sort of more problematic that cookies are used are for tracking, as we saw. So I go to one website, I go to another website, and there's Google's on both of them, and so they know, oh, this is the same person that was on the previous website. It could be used for ads, that kind of thing. They could be monetizing your data too. So it might not be as simple as we're just going to we're going to show you an ad of a website that you were just on. It might be like, hey, we've been watching you for 5 years, and now we know the kinds of stuff that you're into. And so because you're into soccer, we're going to sell your data to some other website, and then maybe you'll get marketing from them or something like that. So there's not obviously a direct connection. Yeah.
Maybe it will be human hacking, the opposite side.
Say again. Sorry.
They hacking the people, the human hacking, yeah?
Yeah.
Something
In a sense, yeah, exactly.
maybe they make a stronger codes, and they know what we do, for example, 5 years after 5 years, yeah?
Yeah, exactly. Yeah, and so and I think I said this before in this class, but the data that's being harvested now, it could be run on the algorithms of today, but it could be run on the algorithms in 5 years, and those algorithms might be much better than the algorithms today. So a lot of people are like, it doesn't bother me because like I'm not that freaked out yet. Like weird things happen. It's kind of uneasy, like when I see ads of other websites and things like that. But I haven't been like totally freaked out by all the data that I've given, right? But in 5 years, corporations or government or whoever the data holder is, they might do something that really freaks you out. But that's based on all the data you've given them over the last 5 years, and it's too late. Now, there is some laws and things like that. You might have heard in like the UK or in Europe, they have the right to be forgotten, which should allow you to go around to these data holders and say, I want all my data deleted. We don't have that in Canada. And it only works for companies that are going to operate under the laws of Europe, for example, that are located in Europe. But if the data holders are offshore somewhere, then they're not necessarily going to follow that policy. The other problem with cookies is session hijacking. So this is where you send your cookie that's keeping you logged in, but you don't send it over HTTPS. Or any of those attacks that we talked about on HTTPS you're able to do. Okay, so whichever the case is, so your session gets hijacked, then I can log in as you. Okay. Now this isn't strictly any worse than sending passwords across the wire too. So cookies didn't create this problem. Anytime you send some sort of secret credential across HTTP, that's a problem. But usually what would happen is, or what used to happen is, I guess developers just didn't have the right mental model of how everything worked. So they would turn HTTPS on only to submit your password. Everyone knew like, oh, don't submit your password over HTTP. So they would turn it on, and then once you were logged in, they would bounce you back to HTTP. But then you would be logged in by your cookie. And so someone can steal your cookie. It's almost as good as stealing your password. It's not quite as good because your password, I can always log in as you. I can change all of your settings and things like that. With your cookie, it's like I can log in for you until it expires, and then I can't. Or until the website decides to not allow the cookie anymore. Or if I go in and try and change your password, it might say, what's your old password before setting a new password. So your cookie might not be enough to change a password or something like that. That's also why I should have phrased it as a question. Why is it that websites want to know your old password when setting a new password? Right? You're logged in, you gave them your password, right? And so it's to prevent session hijacking. So it's because they think it's more likely that someone steals your cookie than steals your password. And so when you go to that site and you're like, I want to change my password, your cookie's what's keeping you logged in and going through all those screens. But then when you go and change your password, then they want to make sure that you're actually the person that knows the password and not someone that just found the cookie for the session. So it stops someone from stealing a cookie and then being able to steal your password by virtue of resetting it. Okay, questions about this? Okay. All right, let's take a 10-minute break. So come back at 7:03, and then we'll keep going. Okay, so let's talk next about cross-site requests. So I'll just draw out that example I gave you in words. So say we have a website. Say it's a news website. Okay, so like a lot of news websites, they like social media. They want, some traction on social media and see whether people like their articles and things like that. So this particular news website might have, they might want to embed some content from Facebook, for example, or Twitter or something like that. Okay, and so what will be used was mentioned is called an iframe. So the main content of the website is going to be coming from some server. And in the HTML of the website that you pull down, there'll be a tag iframe, and then it will point at some other website. So for example, let's assume that's Facebook. Okay, and with an iframe, so we're going to go through the same origin policy. That's what we're leading up to. But iframe elements are completely separated from the other elements on the website. Okay, so news knows that it created an iframe. Okay, it knows where it pointed the iframe. It knows the size of it, like in terms of graphical or whatever, like how many pixels it's giving Facebook or whatever. So it can control that. But what gets put into that iframe is completely controlled by Facebook. Okay? And the news server doesn't know what it is. It doesn't see it. It's like there's a separate HTML page inside this bigger HTML page. Okay? So it's sort of exactly what it is. Okay? So it doesn't see any of this stuff. Okay, so how does the iframe get filled in? What will happen is it'll get filled in, just think of it as like a website inside a website. So exact same way. So the iframe will point to not just a domain, but like usually like an actual URL. Then you'll go over to Facebook and you'll say, okay, I want to request, that particular resource. And when Facebook responds, the content will get dumped into this iframe. Okay. Now let's think about cookies. So let's say that the user has a Facebook cookie. Because this is a request going to Facebook, that cookie is going to get sent. This is a small point, but it's actually not a third-party cookie, even though this looks like a third-party situation. Because it's in an iframe, it's a first-party cookie as far as the iframe is concerned. It is a third party in terms of the website itself. But a third party actually means that that you were requesting, like say, an image from Facebook from the actual the main frame of the website itself, not inside. So an iframe is like kind of like making a mini browser session with like a mini browser window. So anyways, you don't have to worry about that, but just for your interest. So even if you turn off third-party tracking and all of that stuff, it doesn't stop like the Facebook like button and things like that from working on websites. Okay, so it will go through, your browser will go through its cookie jar, and it will drop in any cookie that matches Facebook. So let's say that when you go to this news website, you're actually logged into Facebook. That means you have a session cookie for Facebook, and that means that session cookie is one of the cookies that's getting sent to this request. Okay, so now Facebook will say, oh, I see this cookie came in. I wonder who that is. So I have all my users, and I have all their cookies, values, and then I see that this particular value is Jeremy. So now I know it's Jeremy that's coming to me for Facebook. Okay, so now what it can do is it can customize its response. And so it might show, I don't know what it would show. It might say like, usually like a like button. Let's see if I can draw it. And if I click on that like button, it will like it automatically on Facebook. Okay, I don't have to log in. It's not going to redirect me to Facebook, and then Facebook's going to say, okay, log in, and then it will click the like button. It will just automatically, seamlessly happen. And it might say like, this is a made up example. I don't think Facebook actually does this, but it might say like 2 friends. Like this article. Okay, and so how does it know that 2 friends? Well, because it looked up who I was, and then because I'm logged in, then it says, well, I can provide any information about it, just as if I went to Facebook itself. Okay, now I want to emphasize very clearly that the news website cannot see inside this, even though it's on the news website's page. And from a user perspective, from a user interface perspective, you just see this website come down, right? You go to the URL and it's at news.com, and you see that it says that 2 of your friends like this article, right? It looks like the news website is telling you that information, okay? But they're not. Facebook's telling you that information, and Facebook isn't necessarily telling news. There's nothing that stops, like Facebook could say, hey, Jeremy just logged in, this is what he's looking at, or whatever. So there's nothing to stop information sharing between these 2 sites, but none of that happens automatically. Okay. Okay, so this is called a cross-site request. Any questions about this or how it works? Okay, then let's consider what happens if a cross-site request goes bad. So this is a forgery attack that's very common, and it's called cross-site request forgery. So cross-site requests aren't bad. Okay, they're just this. This is all a cross-site request is. Okay, and then a forgery is what turns it into attack. Okay, so this is how this, I'll show you the basic attack, and there's a million variants of it. You'll take a course 6120, I think, or 6130, 40, something like that, networking. Was it 30? 20? Okay. Anyways, you'll probably look at 5 different ways of doing this and things like that. But here I just want to give you the intuition for it. And then when we see the same origin policy, we'll see why the policies are the way that they are, and why you can't just like turn these attacks off. Okay, so let's say that we have a website again. And this time, let's assume that the website is bad. Okay, so the step one of the attack is I lure you to my website somehow. So maybe I send you an email with a spam link, or I buy Google ads or something like that, or I put some social media posts and I have links to malicious websites. But this is an attack that works if I can get you to the attacker's website. So the attacker is controlling this website. So same thing as before. What I'm going to do is I'm going to embed some content in an iframe. And there should be no problem with this, okay? Because I can't see inside the box. And so I can choose who gets to fill in the box, but I can't see inside of it. So there shouldn't be a security threat or a security problem with me like making an iframe, right? There should be nothing that, this should be a completely safe action. So let's say that I embed a frame for your bank. And another thing I'll note too is that this doesn't actually have to be visible. This can be like a 1 pixel by 1 pixel iframe. So it's just something that happens in the background. You don't even know that it's happening. I don't have to like show you stuff that corresponds to you. So I'll just note. So nearly invisible. Okay, so what will happen is I'm going to send a request, and my request will go out to the bank. Now, if I'm logged into the bank, do my cookies go along with that request? Does my session ID go along with the request? So the answer is yes, for the same reason as before. So far, the picture looks exactly the same.
The cookies of the bank domain.
Of the bank.
Domain,
Yeah, yeah. So cookies that match bank. And so this could include like a session cookie, which means that I'm logged in. Okay, so the bank will get this cookie and they'll say, do I know who this person is? And they'll see that they gave this cookie to me. And so they'll say, okay, yeah, I know this person is, they're logged in, whatever. Okay, so they don't know necessarily that I'm coming to this because it's in an iframe that's on some evil website. Okay, they just know it could be that I just browse directly to this website myself. I type the URL into my computer and press enter. Now there are like refers and things like that. So like if they dug a little deeper in the packet trace, then maybe they could try and get a sense of where this is coming from. But let's assume that they're not doing any of that. They're not doing a packet inspection or anything like that. So they just see a request come in. Okay. Now the other piece of cross-site request forgeries that make it work is, let's say that I'm on the bank website. And so I log into my bank, so that's fine. So now it shows me my accounts. So my checking account has a certain amount of money. So I click on it, and then now I see all my checking stuff, okay? And then let's say I want to transfer money to someone else, okay? So I click on transfer, and I type in all the details of the people I want to transfer the money to, and then I click, send the money, all right? Now, when I go onto the website to transfer the money, does the website remember, they know who I am because of my cookie, okay? But do they remember everywhere I was on the website? Are they like, okay, this is the person that was just on, they were just looking at their checking account, then they clicked on the button, and now they're looking at this particular thing?
It depends.
Okay.
Prefer
Okay,
Referrer had it.
so it depends. So the refer could maybe tell you the immediate predecessor, but what about like sort of the complete history of where you are?
Um,
So it's going to depend on how the website is coded. Okay, so earlier websites, and like if you use My Concordia or something like that, they're going to have like what are called stateful requests. So they're going to write down like, oh, this person with this cookie came and they looked at this page. Then they looked at this page. Then they clicked on this page. And then if you ever have to go back or something like that, they're going to go through their history. They're basically like storing it all. Okay. Now, this is kind of, it's not great from a web perspective because you have to store all this information about all your users and where they are, and you have to remember where they are at all times. Okay. So what people decided to do is let's do a stateless website where you are, and if I care about where you were before, I'm actually going to encode that in the URL. Okay. So for example, if I'm on my checking balance website and I want to go to withdraw, what I'll do is when I pull down the website, the requests from the website's going to put in the URLs for when I click that checking button, what URL does that actually go to? Okay. And so in that URL, it can say, you know, this is being referenced, like the referrer for the person who clicked on this is the checking balance website. Okay. Or the action of I want to send this money. A better way of thinking about it is this. I fill out a bunch of information, like I want to send money to this person. Then I click the next button. Okay. And then it's like, do you want to send it now or do you want to send it later? How does it remember all the stuff that I put on the previous page? Right. And so what it will do is it will encode it in the URL. So I'll get the URL down and all that information will be in the URL. And then when I finish the second page and hit submit, then that submit button will have all of the data from the first page encoded in the URL itself.
you need the attributes with the and
Exactly, yeah. So if you actually look at a URL, let me just show you, and then I'll draw it out. So actually, Google's a good example. So let's just go to Google, Montreal Impact. Actually, CF Montreal. Anyways, whatever. Now Google's weird because Safari likes, it's too smart. It knows that that I'm on Google. So it won't actually show me the URL that I'm on. It will show this. So let's use the search engine that no one ever uses. Okay. So for example, you can see, okay, let me just back up a second. Okay, so I'm on this website. I type in CF Montreal. I hit search. Okay, what's going to happen is it's going to do what's called a post. So it's going to send that information to Bing. Okay, so I do this. Okay, now I'm on this website, so that's fine. Now let's say I don't see what I see on the first results, so I go to the second page of results. Okay, how does Bing remember that I'm the person that searched for CF Montreal? And now I'm looking at the second page of results. Like, how do they know that that's sort of where I am? So one option is they just record it. They're like, this person with this cookie asked for CF Montreal. Then I gave them the first 10 results. Then they click the next page. So now I know exactly where they are. Okay. The other way they can do it is they can encode it in the URL. So if I look at the URL, you can see that the search query is here in the URL itself, CF plus Montreal. Okay. And somewhere in all of this gobbledygook is the fact that I'm on the second page of results. And all of that's in the URL itself. Okay? So what that means is Bing doesn't remember who I am at all. Okay? I could go directly, I could take this URL, type it in manually, and I would automatically go to the second page of the results of Montreal Impact or CF Montreal. Okay? It's not that I had to search for it and then click on the second page. Okay, it's all in the URL itself. If I copy and paste this URL, I email it to you, and you click on it, you're going to go to the second page of results. Okay, so it's sometimes you're doing stuff, you're filling out a form, and you email it to a friend, and they it's not like they jump into the middle of the form with like everything that you filled out. right? It's like it wants to restart the session from scratch, right? So that's like when you have the old school kind of websites. But with this URL rewriting, it's called RESTful architecture. Then yeah, you can send a URL to someone else, or you can bookmark it and come back later, and it will have the exact same stuff filled out that you actually bookmarked. So anyways. Okay, so let's assume that our bank here is using this RESTful architecture. And so the request here that the person embedding in the iframe could look something like this. Okay, so it's you're on bank.com, you're in your account, like script, server-side script, and let's say I wanted to transfer $100 to Eve, so I would fill all that information out, and then when I hit the submit button, it would submit it to this URL. So it would put what I want to do in the URL itself. The website would receive it. It would say, okay, you're logged in, you have a cookie, I can see what you're trying to do because it's in the URL, so then I'll go and I'll transfer that website, okay? I don't know that you filled out the form. I don't know all the previous pages that you've been to. I just see you for the first time. You pop out of thin air, and I know exactly what you want to do, okay? So this is a stateless.
What would be click jacking then? I think it is click jacking.
Okay, sorry, say again.
It's click jacking, I think. It's not like a serious setup we are talking about.
Uh,
I'm thinking about a click jacking. We are talking about iframe, so I think this would be a click jacking attack.
sorry, are you saying clickjacking?
Yes.
And let me come back to that. I'll show you clickjacking. So clickjacking is another way of abusing cross-site request forgeries. This one's even simpler because you don't need the user to even click. So yeah. I'll show you clickjacking later. Yeah, okay. Okay, so this is a stateless, or it's called RESTful. And basically you can have a simpler website. You don't have to have a database that's keeping track of where users are in your web app and things like that. Okay. So let's think about what happens now in this situation. So I go to evil.com. They put an iframe in for bank, and evil.com is filling this information in. Okay, so this is a URL that they know. Like they have to know it. So they're pointing their iframe, which is invisible 1 pixel by 1 pixel, to this URL. Okay. Then what my browser does is it says, okay, I have to go and request this URL. So it sends the request. My browser checks whether I have any cookies for bank.com. It sees I have a session cookie. I'm logged in. So I send this request with the cookie, right? And then it goes to the bank. And then the bank says, oh, I know who that person is because I know their cookie. It's Jeremy. Looks like they're trying to transfer $100 to Eve. And so I'll just send the $100 to Eve. Okay. So so this is a cross-site request forgery because it's a cross-site request. It's a forgery because it wasn't my browser that made this like transfer $100 to Eve, right? It was the website that forged that on my behalf. But because I'm logged in, it just sends it, it executes, and the $100 moves. Okay, so this was a big problem with the web for a long time, and even to this day, you still hear about, cross-site request forgery attacks that happen. Most of the people know about it, so there's some ways of fixing it. that are pretty common, and they're in different libraries and frameworks, so it should happen automatically. But every now and then there's a website that misses it, or they're using some old website or something, or there's some weird corner of the website that people don't use that often that's vulnerable to this kind of attack. Okay, how do we fix this?
By adding token to this session.
Okay, so that's the correct answer, but tell me the logistics of that.
Like a session ID connected with the with the token. When we are sending a request every time, it check with session. It is a binding with each other.
Yeah, okay. So that's exactly the right answer, but who's we in those scenarios? So,
Server.
yeah.
Session ID server confirm with the every time token.
Yeah.
Like with the every request.
Okay, so who, okay, let me explain it and you tell me whether you agree or not. So I'm going to go to bank.com.transfer.100. I'm going to go in my cookie jar, I'm going to grab my value, and I'm going to stick it on the end. Yeah?
No.
Okay. So first off, just let's pause. Why does that not work? So if I go to my cookie jar and my browser could write that cookie value into the URL and then it would get sent.
So I think the session is not confirming. Maybe there is a session with request.
Okay, the problem with that is I still can't distinguish whether the user themselves sent this request or the fraudulent website. Okay, so I need a URL that looks different when it's coming from an iframe that's embedded into a website from one that's coming from me actually browsing the actual website of the bank. Okay, any other ideas? So that's right. What you said is absolutely right. It's just the logistics of who's doing what. Okay, so what we're going to do is, first off, let's say I'm actually using the website for real. Okay, so at some point I go to this URL. Who gave me that URL to go to?
If you are using it, you click for, let's say, account.php, then transfer, then eve.
That's right. So I went through the process. I'm actually using it. I went through all those websites. But who is it that decided, who was it that put transfer 100 and to Eve into that URL? Okay, so it's either me or the server, right? It's either my browser, my website, or the server. So which was it? Okay, so it's the server. So what the server's doing is they're rewriting all the URLs on the website based on whatever information they want for me. Okay? So the server can put any value that it wants inside that URL. Now let's say the server dropped my cookie into that URL. When I'm using the website itself, then the server can always add my cookie to those URLs. Okay? So that's fine. Could the website, this iframe, who is it that chooses the URL that this iframe points at? So who was it that wrote out this URL for this iframe to point at?
The person that created
Okay, so the evil person here. Yeah, okay. So if I had a policy that every RESTful URL has to have the user's cookie embedded in it, could the adversary make an iframe that points to the bank with my cookie value in it? No, not without knowing my cookie. Right, so assuming my cookie is secret, then it can't make that URL. Can the bank make that URL?
Yes, you can.
Yes, because it set the cookie in the first place. It has a record of all the cookies, okay? So that's a URL that only the bank can create. Okay, a bad person can't create that URL on their website. So that's in general how you would solve this particular problem.
There is CSRF tokens.
Sorry?
There is CSRF tokens.
There's
CSRF tokens.
CSRF?
Yeah.
Yeah, okay. Yeah, that's the name, yeah.
They don't usually use cookies for this. They use another token called CSRF token.
Yeah, but it is a cookie value that's being stored, ultimately. Yeah, I think. Yeah, okay. All right, so the solution would be you do bank.com /account bank.php, whatever, transfer. And then you could have a cookie ID, session ID, something like that. Okay. Now it's really important that it's already important because your cookie is going to be prepended regardless, but it's really important that this goes over HTTPS. Okay. If this didn't go over HTTPS, if it went over HTTP, let's say I had a cookie, but it was marked as secure, then my browser won't put it in. So it's not going to leak my session ID, but it's in the URL. So then it's going to leak through the URL. So my cookie is actually in two places. When I request this, this is the actual request. And so my cookie value is here. But then my browser's still putting my cookie in the packet header itself. Okay, so it's really simple for the bank.com. In fact, they arguably don't even have to go looking up my cookie in their database. They really just want to check whether the cookie that's here is the same as the cookie value that's here. So this, specifically this here, is something that only the real bank can do, okay? So the fraudulent website, they can have this cookie inserted, and they can have the URL, but they don't know what value to stick here. They have to guess what value it is and hope that it matches this value. If they knew the value to stick here, then they already have your cookie, then they could just session hijack you anyways, okay? So it's not making anything worse by sticking the cookie there, provided that you go over HTTPS, okay? If you don't go over HTTPS, then you are making it worse because you're exposing your cookie. Okay, and then if we go, even like, I'm not logged into Bing at all, but still you'll see that they still do it. So here, cvid. And so that will be a cookie that corresponds to something that's set in my browser. We can actually go try and find that cookie, though sometimes they use different names for things or different encoding, so it doesn't show up looking exactly the same. So this is still showing me. Yeah, okay, so I don't see it's not obvious where that is, but it could be re-encoded or something slightly different. But anyway, sometimes you can see the cookie in the URL and you can see it in the cookie store itself directly. Okay, is there any questions about this?
Can you try to find the CVID in the source code?
Yeah. Now we're in the experimental part of class. So it might be so this is just the URL itself. So like it's probably when I click on the next button, then it's so if I click here, for example, then it's going to redirect to a URL that also includes the same value. So it just rewrote those URLs on the fly. But yeah.
I want to see that put as a hidden value or something.
Right. Okay, other questions or comments about this? Okay, so this is unusual. Most years people are like talking forever and then the content takes longer to go through. But this year we're like breezing through it because everyone's quiet and shy. So that's actually to your advantage because that means we're going to end class early. And we have one lecture left. So next lecture will be covered and then it's going to be the exam. And so, yeah, there's, I'll have no problem going through the rest of the material by next lecture itself. So why don't we take a break tonight? And even next lecture might not be the full lecture itself. All right. All right, good. We'll see you all next week.